हेलो स्टूडेंट्स, आज मैं आपके लिए लाया हूँ जेई एडवांस प्रैक्टिस प्रॉब्लम ऑन डिफरेंशिएशन ऑफ डेफिनेट इंटीग्रल्स। आइए देखते हैं क्या क्वेश्चन है। क्वेश्चन सेज लेट एफ ऑफ एक्स बी डिफाइंड एज बिलो इन द डोमेन ओपन इंटरवल 0 to 1. F of x is equal to integral from e to the power sine inverse x to e to the power cos inverse x tan of ln t dt, and then we have to select that which is or are true. So f of x is increasing at x is equal to half, or f of x is decreasing at x is equal to half. And then it is asking if f dash at half is equal to a to the power pi by 3 plus be to the power pi by 6, where a and b are constants, then a is equal to 3b. Or if, and the last option is if f dash of half is a to the power pi by 3 plus b to the power pi by 6, where a and b are constants, then 3a is equal to b. So basically it's asking that whether the function is increasing or decreasing at x equal to half, or and then also that the value of f dash x, if I am expressing it in this format, then whether a becomes equal to 3b or 3a becomes equal to b. So if we are able to find out the value of f dash x at half, then we will be able to tell answer all the entire question. Because if we know like what is whether the value of f dash x at x is equal to half, if it is negative, then we can say that the function x is decreasing. If it is coming positive, then it means the function x is increasing. And then if I know the value, I can express it in the format given, and then I can find the value of a and b and then compare them. तो आइए देखते हैं इसका कैसे सॉल्यूशन करते हैं. So as I said कि हम लोग को f dash x find करना होगा. So finding f dash x means differentiating this entire integral that is given to us. ऐसे नॉर्मल वे में अगर इसको डिफरेंशिएट करने जाएं, पहले इंटीग्रेट करके फिर डिफरेंशिएट करने जाएं, it will be very complicated and it will be time taking. So there is something called, as you people might already be aware, Leibniz rule of differentiating indefinite integrals. Leibniz rule of differentiation for definite integrals. In case you are not aware about this, there is a video available in our playlist. You can please go and watch it. But as far as this question is concerned, we can break down it with Leibniz rule. एक बार देख लेते हैं यहाँ पर भी कि कैसे ये इसका formulation क्या होता है basically. So let's say that if there is a function f of x is equal to integral from a of x to b of x gt dt given to us. So this is the integral that you can see like it is following almost the same, not almost, but exactly the same format as the problem. Like we have f of x, and then we have the lower limit which is a function of x, we have upper limit which is a function of x, and then there is g of t which is tan of ln of t in this case. So here you can see that a of x is nothing but e to the power sine inverse x, b is nothing but e to the power cos inverse x, and g of t is nothing but tan of ln t. So it is exactly comparing with this format. Now if this is the format of the definite integral where the limits are themselves the functions of x, then we can find f dash x using Leibniz rule, which says function dash x will be equal to the value of g function at the upper limit first, which means value of g at b of x multiplied by b dash x, which means we are taking the differential of b or the upper limit with the b of x or the upper limit with respect to x, and then minus again the value of g at the lower limit, which is a of x multiplied by a dash of x, which means differentiation of the lower limit with respect to x. So this is what the formula of Leibniz rule says, and now we can apply this same formula on our question directly and see what comes out as f dash x. So now let's try to find out f dash x with help of Leibniz rule. So यहाँ पर f dash x will be equal to the value of the function which is given as tan of ln t के जगह पर अब हम लोग लोअर लिमिट लगा देंगे. So it will be tan of ln of e to the power, sorry, first we will put the upper limit. So it will be tan of ln of e to the power cos inverse x, cos inverse x into d of e to the power cos inverse x, e to the power cos inverse x upon dx. This is one part, and the second part will be minus again tan of ln of, this time we will put the lower limit in place of t, so e to the power sine inverse x into d by dx of e to the power sine inverse x. So this is our function as x if we put the formulation of Leibniz. So now let's little bit simplify it. So you can see here that ln of e to the power cos x, this thing will be nothing but cos inverse x. Same way ln of e to the power sine inverse x will be nothing but sine inverse of x. So with that it will turn out to be tan of cos inverse x into, now finding the differentiation of e to the power cos inverse x. So with respect to x, so first we'll differentiate with respect to cos inverse x, so it will become e to the power cos inverse x multiplied by d of cos inverse x by dx. So you already know the differentiation of cos inverse x comes out to be minus 1 upon root under 1 minus x square. So this is the differentiation of cos inverse x. Remember there is a minus sign over here. So this is what we are getting for the first part. Now let's see the second part, which is minus. Now again here it will be tan of, this has already converted into sine inverse x. So tan of sine inverse x into d by dx of e to the power sine inverse x, which means we will first differentiate with respect to sine inverse x. So we'll get e to the power sine inverse x into d of sine inverse x by dx, which will give us 1 upon root under 1 minus x square. So this is what the next step would be. आइए देखते हैं next step इसके बाद. So in the next step we will try to find out tan of cos inverse x and tan of sine inverse x. Remaining things I think are already pretty much in good shape. So let's try to find out tan inverse of, sorry, tan of cos inverse x. So in order to find this quickly, there is one way that I do. I mean, you can directly remember the formula also, no issues in that. But this is what I generally follow. When it is cos inverse x, I generally call it theta, and then I can make a right angle triangle with calling this angle as theta, and this means that if this is the situation, cos inverse x will mean that my base will be x and my hypotenuse will be 1. So this is the situation which will be created when we are having cos inverse of x equal to theta, right? And now in if this is the situation, then my perpendicular will be root under 1 minus x square. So therefore now if I have to find tan of cos inverse x, which means tan of theta, from this diagram you can see that tan of theta will become root under 1 minus x square upon x, right? Now same way if I have to find tan of sine inverse x, I again assume it to be, let's say, alpha, and then again try to draw a similar kind of triangle, a right angle triangle with this angle as being alpha. And in this situation, since sine of alpha is equal to x, so that means perpendicular must be x and hypotenuse, let's say, is 1. In this situation the base will turn out to be 1 minus x, root under 1 minus x square. So now if I have to find tan of this alpha or tan of sine inverse x. So tan of this alpha will become equal to x upon root under 1 minus x square. So now I can substitute these two values over here. So now let's substitute those values in this equation. Will get tan of cos inverse x, we saw it is coming to be root under 1 minus x square upon x into e to the power cos inverse x, and I will bring this minus sign up front now. So minus divided by root under 1 minus x square, and then again there is a minus for the second term. The second term tan of sine inverse x will become x by root under 1 minus x square, and then multiplied with e to the power sine inverse x, and then at the bottom denominator we will have root under 1 minus x square again. So this is what the next step looks like. Now let's see the next step from here. Now we can see that this and this will cancel out. So we are just left with minus of e to the power cos inverse x by x, and then minus, and this side we have, or the second term is x by 1 minus x square e to the power sine inverse x. So that's what the value that we are getting for f dash x. Now we can put f dash of half and see what is coming. So the first part will become minus e to the power cos inverse of half. We already know it is pi by 3 divided by 1 by 2 minus x is 1 by 2 into 1 minus 1 by 2 whole square will give me 3 by 4, and then e on the top I will have e to the power sine inverse of 1 by 2, which will give me e to the power pi by 6. Therefore it will come out to be minus e to the power pi by 3. This 2 goes up, so it will be minus 2 e to the power minus pi by 3, minus this becomes basically 2 into 3 by 4 will become basically 2 by 3, 2 by 3 e to the power pi on 6. So this is what the value that I am getting. Now looking at this value, you can directly see that e to the power pi by 3 is a positive number, and then e to the power pi by 6 is also a positive number. So therefore you can take out minus sign from here thoroughly. Still you will be left with minus sign outside, and then there will be 2 e to the power pi by 3 plus 2 by 3 e to the power e to the power pi by 6, e to the power pi by 6. So this number inside the bracket is purely a positive number. E to the power pi by 3 we know is a positive number, e to the power pi by 6 is a positive number, 2 and 2 by 3 are again positive number, they are being added, so definitely it's going to be a positive number. But we have a minus sign in front of it, which will make the number negative. So this means that f dash at half is a negative number, and therefore we have seen already, we just talked about that if we are getting a negative slope at x is equal to half, then that means my function must be decreasing at x equal to half. So that means my B option seems to be correct. So now that we know f dash half is equal to minus of 2 e to the power 2 by 3 plus 2 e to the power pi by 3 plus 2 by 3 e to the power pi by 6. So now we can compare it to the format that is being asked for as per option C and D. So clearly A we can see is equal to minus 2, and also we are seeing that B is equal to or can be compared to minus of 2 upon 3. So therefore from this we can directly say that A is nothing but 3 times of B. So that is what we are seeing from the values that we have at hand, and that option is A is equal to 3B, which is the option C. So my option C is correct. So therefore option B and C are the correct choices for this question. So hope you enjoyed this video and got a good practice problem to solve, which was based on Leibniz differentiation of definite integral. I will be coming up with more such JEE advanced practice problems. So please subscribe and like our channel for more content, and also share it with your friends who are preparing for JEE advanced mains, or they are in class 12 and can get and for whom the content can be of use. So keep learning, keep enjoying, and stay tuned to our channel. Thank you for watching, and we'll return back with the next topic, next question, next video again. Thank you. Bye.